is one of the world's great success stories. Global audience, commercial appeal, and often an ideal role model for business. For 2 hours on a Sunday, it's a sport. The rest of the time, it's a business, and one of the most technologically advanced at that.
F1 involves a level of complexity, and a level particularly of technological complexity. You're really talking about the pinnacle of a global sport.
Formula One is unique. It's where human endeavour meets technological achievement.
The drivers are incredibly important, but unlike many other sports, it also the technology that goes into their equipment that is so dominant in the results that we get.
It's the pinnacle of all motorsport, where some of the world's finest engineers compete to create the perfect racing machine.
The Formula One car is the ultimate ground vehicle. We take everything that's common in a car and we just take it that little bit further.
In this episode of Formula for Success, we look at the role of technology in both Formula One and in business, and how it can be used to gain an edge over one's competitors. The Formula One car we see today is the result of over 70 years of technological development. Back in the 1950s, the cars were designed primarily for straight-line speed. With the engines mounted in the front and precious little safety equipment, the drivers battled to control their machines on treacherous circuits. By the 60s, the engine was moved behind the driver to help control the cars and increase cornering speeds. With the sport loosely regulated, men like Colin Chapman at Lotus were able to come up with significant leaps in design, if they could afford it.
Colin Chapman, to us young sort of design guys, was the great innovator. The thing with Colin was he wasn't just good technically, he was good commercially as well. So he literally could sit on the top of the organisational pyramid and do both. I don't know anybody else that's been able to do that.
Chapman and rivals like Enzo Ferrari pushed technology to the boundaries. By the 1970s, developments in tyre technology had led to the engine becoming a fully integrated part of the chassis, enabling cars to withstand even greater speeds. It was an era when designers played cat and mouse with the regulators. The most visual example was the Tyrrell P34 six-wheeler. In 1976, it won the Swedish Grand Prix, but the project was soon cancelled due to problems with tyre development. By then, a new and ingenious innovation was about to hit Formula One: ground effect. In a bid to increase the downforce, Lotus experimented with channeling air underneath the car.
The big secret was to have sliding skirts along the side of the car to protect the low pressure area. These would run along the surface of the track. The cornering speeds went up dramatically, and that was the big secret to this car's success. When ground effect came along, no one really understood what we'd done, and then they couldn't incorporate it to their existing cars anyway. It wasn't something you could copy and bolt on. You had to throw away your existing car and make a new one.
The other teams were desperate to catch up. One solution was the BT46B fan car, built by Bernie Ecclestone's Brabham, which used a massive fan to suck the car to the ground. The design was banned after a single Grand Prix win. In the 80s, two new leaders came to dominate Formula One: Ron Dennis at the McLaren team and Frank Williams at Williams F1. The authorities would continue to regulate technology as a host of new electronic innovations came to the aid of drivers. In 1992, Nigel Mansell's World Championship winning Williams car carried active suspension, a semi-automatic gearbox and traction control.
There were occasions where Nigel Mansell was able to qualify his FW14B sometimes the better part of 2 seconds a lap quicker than rivals Ayrton Senna and Michael Schumacher. Mansell was the equal of those guys in ability and speed, so you have to give credit to the car for the advantage that was sometimes displayed during the 1992 season.
With the leaps in technology came further regulation from the sport's governing body, the FIA.
If you're going to have a Drivers' World Championship, they've got to drive. So then you've got to draw a line between what is allowed and what isn't allowed, because there's an enormous amount of electronics on the cars now, and one or two things have escaped. You know, we weren't quick enough to stop them.
Speeds would rise and fall with regulation changes. These were partly driven by safety concerns, especially after the death of Ayrton Senna in 1994. Another issue has been the spiralling constructors' costs that have forced the smaller teams off the grid.
It's very expensive, and for that reason we want to get the costs down, because it's nice to have the major motor manufacturers here, but they're in Formula One as long as it suits them, and if something happens where it no longer suits them, they'll be gone. Whereas the Frank Williamses of this world, who have an independent team, that's their business, that's what they do, and provided they can survive, they'll be there forever, so we must look after them.
In order to compete in Formula One, teams like Williams have created working environments that would be the envy of any commercial research and development facility.
The facilities here are geared towards developing and producing the cars. So we have 2 wind tunnels that we use for the aerodynamic development of the car. They're backed up by a very large rapid prototyping facility, producing parts very quickly. We then have extensive production facilities, so we're doing machining work in-house, we're doing a lot of composite work in-house with carbon fibres, so that we can make most of the cars in-house, which is the quickest way to do it. Coupled with that, we have a very large team of extremely skilled people, and so we have everything that we need here to create a successful Formula One car.
The result is that Formula One has become a showcase for the latest and most advanced technologies. All the top teams will work with technology partners.
For technology partners, the opportunity to build a technology case study using the team is often quite an attractive one. We have people like Ray's Wheels or Puma or Bridgestone. They give us things that we actually need to compete and to go racing. We've got AT&T and Lenovo. AT&T have taken over responsibility for all of the data traffic, of which there is masses.
What AT&T's technology has allowed them to do is quickly communicate on probably 5 to 6 times faster than they were able to do in previous seasons, to analyze data, to make a decision and assessments, and spend more time now making modifications, talking to drivers about techniques, and giving the team better instructions so that they're able to have a better race.
So with Lenovo, we make PCs. In fact, a Formula One car starts because of a notebook computer. So from ignition all the way till the end of the race, we use our PCs across the board. And we're also starting to work with Williams on computational fluid dynamics, optimizing airflows on cars. Because in this racing space, when things start to get commoditized, you need an edge. Everyone's looking for an edge. Just like we are in business, so in car racing.
The names on the car's liveries are testament to the high-tech working relationships that form the basis of a team's performance. Partnerships mean teams can access and share new ideas and technologies. They've consistently helped to develop products that trickle down from F1 to benefit the consumer. After the break, we look at how the mass market has benefited from the research and development that's carried out in F1. Formula One is fast, glamorous and global. Its attraction to big business has allowed it to pour millions of dollars every year into funding the research and development of new technologies. The drivers may front the sport, but the car and the technology behind it is just as much the star.
I think there are many things that surprise people about Formula One cars. Our engines, 700 horsepower from 2.4 litres. They rev to 19,000 RPM, that's 3 times the speed of a road engine. Our cars can brake at 5G. What does that mean? It's almost like having an accident. We have so much downforce on the car that actually if you flipped it upside down, you could drive it along the roof of a tunnel at less than 100 miles an hour. They really are special machines.
They may be special, but they're also very expensive, and the prohibitive costs mean you won't find much of a Formula One car in your everyday road car.
Whereas if you dig deep, you find there isn't a lot of technology transfer because the worlds are so different. The world of high volume car manufacturing is all about cost. It's taking $1 off of each door manufacturer, whereas for us it's can we make the door handle out of titanium because it's going to save 3 grams. very, very different. But certainly Formula One has had an influence, and it's having an increasing influence, not the physical bits or the detailed technology, but the tools that we use, the methodologies that we use. That's becoming more and more relevant.
Exploring commercial applications of technology is exactly the reason why car manufacturers like Honda are now fully committed to Formula One.
There are many technologies within Formula One that translate into a road car where the customer can benefit. The processes and the software that's developed in Formula One can also be used on road cars, for instance, to improve fuel economy, better structures, higher safety in the car. The Formula One cars are very safe because they travel at exceedingly high speeds, and some of that technology gets transferred into a Honda motor car.
When it comes to safety, Formula One has been instrumental in the development of one of the great technologies of recent years, carbon fiber composites. Originally used in the aerospace industry, the former McLaren chief designer John Barnard adapted it to replace aluminium on the chassis of an F1 car.
What I was talking about was something completely different, which was to build the whole monocoque from carbon fibre. And it was a big step.
The result was 1981's MP4 Mark I. And after driver John Watson walked away unharmed from a huge crash at Monza, highlighting carbon fiber's safety credentials, every team followed suit, pouring in money to develop the material.
So the basic philosophy behind driver protection in F1 is that you build a so-called survival cell, this stiff, strong box that contains the driver and the fuel, and it looks after him in the event of an accident. What we do is to put specifically designed energy absorbers around the driver. There's one on the front of the car, that's the nose box. That's actually there to be crushed. In the event of a frontal impact, that nose should crush. And from those early primary structures, we've sort of extended the uses of the materials in all directions.
After almost 30 years of advancements in F1, the aviation industry is now using composites. The Boeing 787 Dreamliner, unveiled in July 2007, is 50% carbon fiber, including the fuselage and the wings. F1 technology also benefits the consumer on the forecourt. The research that oil companies carry out in Formula One leads to better products at the pumps.
After 10 years working in Formula One, developing new products all the time, you had the chance to discover new raw materials, to understand how each component interacts with the engine. This is very important to develop the commercial fuels. The top fuel Petrobras has in the petrol stations today is the Podium fuel, which was developed using all the technology we gained developing fuels for Formula One.
In F1, teams have an acute understanding of the need for speed in design and manufacture. Fast turnaround is the norm. In business, it can mean getting a product onto the market quicker.
I think that F1 is seen as a good role model for business because our time to market, we actually call it time to track, is very short. We can go from concept to obsolescence of a major aerodynamic device, such as a front wing of the car, in about 6 weeks. So that's from initial concept to use in anger at a Grand Prix, maybe 2 or 3 races, and then that product will have completed its full life and become a museum piece because it's been replaced by the next generation coming through.
Technology partners benefit from Formula One's rapid prototyping approach.
Exploiting the technology that we invent very quickly obviously gives us specific competitive advantage. So the speed it takes us to realise the value of that technology that we've invented is paramount to our business performance.
The speed of response is extremely important. It's exactly like with the Formula One teams. I mean, these guys have 2 weeks to tune the car in a different way. Fortunately enough, we get a little bit more time to do it, but they are looking for thousands of seconds. We're looking for 20, 10, 20, 30 microns to shave off a beard. And in that sense, there are quite a few similarities. In principle, they're looking for the same thing. They're looking for a technology jump.
Even race software has been manipulated to help business manage its strategies and decision-making. It's the brainchild of former McLaren partner Smith Bayes.
But when we saw the software used in Formula One, there was a real eureka moment of that's exactly the thinking that we've been progressing. during a race, it's critical to be able to recalibrate what your strategy is or what you think your best action is as events are unfolding around you. And I think that's something that business can learn a lot from.
Their software package creates business scenarios that help companies respond quickly and evaluate risk in today's ever-changing business environments. That same risk is what F1 specializes in. Finding and exploiting new technologies can give a team or business a huge advantage. In many cases, the technology is borrowed from other industries.
I would say Formula One is probably 80% scavenger, 20% creator. We borrow an awful lot of technology. A good example is our carbon fibre brakes that we use. They actually came from the bit that they cut out of the middle of aircraft brakes, and it just happened to be a good size for Formula One.
This adaptation of technologies can give consumer companies an edge in the market. Games manufacturer Nintendo found its inspiration from the car industry.
Nintendo were very clever. They used motion-sensitive controllers to really give the gamer a completely different experience. The Wii remote control, it uses infrared technology, but it also uses accelerometers, which sense motion. It senses it swinging around, and those accelerometers have been driven by the car industry, which use them in airbag deployment systems. And that's one of the reasons why they've become so affordable and could be used within a games console that costs less than £200.
From road cars to aviation, Formula One has always adopted and improved new technologies. The teams have created environments that encourage innovation.
In racing, you want people to be stretching their knowledge to the limits, pushing the boundaries of science. This means if you give them a task, you don't know whether it will be successful, but you push them to execute it properly. And what we had at Cosworth was a wonderful cup called the Catastrophe Cup. And this only got awarded for a magnificently executed cock-up. And that really is the ethos you need, because that guy, you haven't turned him off having another good idea.
This mindset is essential if companies are going to make technological breakthroughs in the marketplace.
It's very important to allow people to go off and try ideas, or allow people to make suggestions, allow people to make mistakes, particularly when you're trying new ideas. I think by encouraging people to say outrageous things, encouraging the people to make silly suggestions, you get onto a wholly different way of doing something and hopefully make new discoveries.
Dyson's revolutionary vacuum cleaner took the industry by storm, claiming 40% of the market in the UK. Such dominance was down to the advanced technology.
If you've got new technology, you don't need to market it in the sort of conventional sense of marketing. You don't have to make up some wonderful claim. You just say why you did it.
With F1's financial muscle, the resources necessary to create the best technologies are almost always available. Winning is the goal at any cost, and it drives engineering excellence.
I think one of the things we're very good at in Formula One is to take a leading edge technology and we commercialize it extremely quickly. We turn it into a usable product. It's a twinkle in a scientist's eye, and we are the engineers who can take it and exploit it. Our success depends on application of technology. So if we want to be successful, and we do, then we have to apply technology better than other people.
In F1, there's always been technology transfer as people move between teams, but the pressure to win has often led to allegations of spying. On September the 13th, 2007, McLaren was found guilty of possessing 780 pages of technical documents belonging to their rival Ferrari.
If the suggestion is that there's been the wholesale illegitimate transfer of technology from one team to another, then that becomes very serious, because it does destroy the championship. It's not fair.
The FIA banned McLaren from the Constructors' Championship and fined them $100 million. As in business, the stakes are high at the cutting edge. Throughout its checkered history, Formula One has always remained at the pinnacle of motorsport and at the forefront of technology. This has made the sport a hotbed for engineering excellence and the ideal environment for innovation. There are plenty of lessons for business. The speed with which everything happens is becoming increasingly relevant to the commercial world. Designers and engineers must be given the freedom to make new discoveries, but it must happen fast or they'll be left behind. In the next show, we look at the teamwork which exists at every level of a Formula One organisation and how business can use it to ensure that they're performing at the limit.